3,000 miles beneath your feet right now, as you sit there watching this, something is moving. Something the size of the moon. Something made of solid metal, hotter than the surface of the sun, spinning inside our planet like a heart beating inside a chest. And for almost the entire history of the human race, we assumed it did the same thing every single day. The way it always had. The way it always would. We assumed it was steady, permanent, unchanging. We were wrong. Because in the last 2 years, a group of scientists confirmed something that stopped even the researchers themselves cold in their tracks. That giant ball of metal at the center of the Earth has slowed down. It has stopped keeping pace with the rest of the planet. And then it did something that sounds impossible until you understand exactly how it was measured. It started moving backwards. And just when the scientists thought they finally had it figured out, the data whispered something else, something no one had ever detected before in the entire history of Earth science. The core wasn't just slowing, it was changing its shape. This is one of those stories where the deeper you go, the stranger it gets. So stay with me, because by the end of this, you're going to understand a part of your own planet that almost nobody on Earth actually knows about. I am Your Name, and this is your channel. If you come here for the real science, the kind that's actually been confirmed and not just clickbait, subscribe right now, because we go this deep every single week. Now let me take you all the way down. To understand what just changed, you first have to understand where it changed. And that means taking a journey straight down into the Earth, through layers most people have never really thought about. Start at the surface, the ground under your feet, the thin crust of rock we live our entire lives on top of. It feels enormous. It feels like the whole world. But in the scale of the planet, it is thinner than the skin on an apple. Go deeper and you reach the mantle, thousands of miles of hot, slowly flowing rock that churns over millions of years. Keep going and the pressure and heat rise until you hit something completely different. You reach the outer core, a vast ocean of liquid metal, molten iron and nickel, swirling and churning, so violently turbulent that its motion is what generates the magnetic field that shields our entire planet from deadly radiation from space. Without that swirling metal ocean, life on the surface would be scorched away. And then, right at the very center of it all, more than 3,000 miles down, past the churning liquid metal, you reach the thing this entire story is about. A solid ball of iron and nickel, roughly the size of the moon, locked in place at the heart of our world, floating in the liquid metal around it and spinning. This is the inner core, and here is the first thing that should stop you. No human being has ever seen it. No probe has ever touched it. No drill will ever reach it. The deepest hole humanity has ever dug goes down about 7.5 miles. The inner core is more than 400 times deeper than that. We will land people on other worlds before we ever physically reach the center of our own. So the obvious question becomes, if we can never go there, if we can never see it, then how on earth do scientists know it exists at all, and how could they possibly know that it just changed? The answer is one of the most brilliant pieces of scientific detective work you will ever hear about, and it starts with earthquakes. When a large earthquake happens anywhere on the planet, it doesn't just shake the ground near the fault, it sends waves of energy traveling straight through the entire body of the Earth. These are called seismic waves. So when they move through the planet like ripples through a giant bell, some of them pass right through the core and come out the other side, where sensitive instruments called seismometers pick them up. And here's the genius part. As those waves travel through different materials, through solid rock, through liquid metal, through the solid inner core, they change. They speed up, they slow down, they bend, they get quieter or louder. So by carefully measuring exactly how a wave looks when it comes out the far side of the planet, scientists can work backwards and figure out what it must have passed through on the way. The earthquakes are the flashlight. The whole planet is what they're illuminating. And the inner core is the shadow at the very center of the beam. That's how we discovered the inner core in the first place. A Danish seismologist named Inge Lehmann figured out it existed back in 1936, just by studying how earthquake waves behaved. Nearly 100 years ago, a scientist proved there was a solid ball at the center of the Earth without ever getting anywhere near it. But here's where the modern mystery begins. For decades, all scientists have argued about one specific question. Does that inner core spin at the same speed as the rest of the planet? Or does it have a mind of its own, turning faster or slower than the ground we stand on? Because the inner core isn't bolted to the rest of the Earth. It's suspended in that ocean of liquid metal, which means it's free to rotate at its own pace, independent of everything above it, like a top spinning inside a larger top. And for 20 years, the scientific community was genuinely divided. Some researchers were convinced the inner core spun faster than the surface, others weren't so sure. The data was messy, the signals were faint, and the whole thing sat unresolved for 2 full decades. It was one of the great unanswered questions about the planet we live on. And then a team led by a scientist named John Vidal at the University of Southern California working with a researcher named Wei Wang from the Chinese Academy of Sciences, decided to settle it once and for all. And they had a clever way to do it. Instead of relying on random earthquakes, they used something called repeating earthquakes. These are earthquakes that happen in the exact same spot, at the exact same strength, over and over again across the years. And because they're identical, they produce nearly identical seismic waves. Which means if the wave from a 1995 earthquake comes out looking different from the wave of an identical earthquake in 2010, something between those two dates must have changed deep inside the planet. It's like taking the same photograph of the same room every few years and watching for the one object that quietly moved. They focused on a seismic hotspot near the South Sandwich Islands, down near Antarctica, one of the most active earthquake zones on the planet. And they gathered decades of data, not a handful of earthquakes, but around 121 repeating earthquakes stretching from 1991 all the way to recent years, recorded at stations on the far side of the world in Alaska and Canada. And when Vidal first looked at what the data was telling him, he didn't believe it. He said, and I want you to hear this from the scientist himself, that when he first saw the seismograms hinting at this change, he was, in his words, stumped. The pattern didn't fit what anyone expected. But then his team found another observation showing the same thing, and another, and 24 more. And at that point, the conclusion became, as he described it, inescapable. The inner core had slowed down. For the first time in decades, the solid metal heart of our planet was no longer keeping pace with the world around it. Here is the sequence they pieced together, and it is remarkable. Back in the past, the inner core was spinning slightly faster than the surface of the Earth, racing ahead of the ground we walk on. But somewhere around the year 2008 to 2010, that changed. The core slowed. At one point, it matched the Earth's spin exactly, and then it kept slowing until it was actually turning slower than the surface. And when something turns slower than the thing around it, from the perspective of that thing, it appears to be turning backwards. That is what the headlines meant when they said the core reversed. It hadn't literally flipped its direction in space. It had slowed down so much relative to the rest of the planet that it was now drifting backwards compared to the ground under your feet. Vidal summed up the whole 20-year argument in one sentence. He said, "We've been arguing about this for 20 years, and I think this nails it." Now, before your mind runs to the worst possible place, let me be completely honest with you, because this channel does not lie to you for views. This does not mean the Earth is about to stop spinning. It does not mean the planet is about to flip over. It does not mean the end of the world. The changes we're talking about are small, subtle shifts measured against the surface, and they appear to be part of a natural rhythm. Because here's the truly fascinating part. When the team looked at the bigger picture, they found this slowdown wasn't a one-time freak event. It was part of a cycle, a pattern that seems to repeat roughly every 70 years. The core speeds up, then slows down, then speeds up again, in a slow multi-decade oscillation, like a swing gradually rocking back and forth on a timescale longer than a human lifetime. In fact, the researchers predicted that in the next 5 to 10 years, the inner core should begin speeding up again, swinging back the other way. So this isn't a catastrophe, it's a heartbeat, a geological pulse buried at the center of the world that we've only just learned how to feel. And that alone would be an incredible story, a confirmed, measurable rhythm inside the Earth that no human ever knew existed. But this is where the story takes its second turn, because that same team, using that same treasure trove of earthquake data, went back to look again. And what they found the second time was even stranger than the first. Here's what happened. As Vidal and his colleagues were studying the rotation, one particular set of data curiously stood out from all the rest. It didn't fit. The core's changing spin could explain a lot of what they were seeing, but it couldn't explain everything. There were wiggles in the seismic waves, tiny changes in the shape and height of the signals. That rotation alone simply could not account for. And at first, it confounded him. He said the dataset confounded him. He was staring at graphs of ground vibrations, trying to make sense of a pattern that shouldn't have been there. And then, slowly, the truth dawned on him. He later said, and this line gives me chills, that he would come to realize he was staring at evidence that the inner core is not solid. Or at least, not solid in the simple, frozen, permanent way everyone had always assumed. Here's how they cracked it. The team took pairs of those repeating earthquakes, but this time they were incredibly precise. They deliberately chose pairs of earthquakes that happened when the inner core was in the exact same rotational position. Same spot in its spin, which meant rotation could be completely ruled out as an explanation. If the waves still looked different, it had to be because something else had changed. And that's exactly what they found. Between roughly 2004 and 2008, waves traveling to a station in Yellowknife, Canada, changed in a way that couldn't be explained by rotation at all, while waves reaching Alaska stayed consistent. The only thing that could account for it was this. The surface of the inner core itself was physically changing, rising and falling, shifting. The solid metal ball at the center of the Earth was deforming. It was, in a word, almost too strange to say out loud about the center of a planet, shape-shifting. Let that settle for a second. For your entire life, and for the entire history of science before you, the picture in every textbook was of a smooth, solid, unchanging iron ball at the heart of the world. A permanent thing, a fixed point. And this research suggests that picture is wrong. The near surface of the inner core appears to be soft enough to move, to flex. The scientists described it as a slow, viscous deformation, a bit like tar, changing its shape over time. The metal isn't melting into a puddle, but its outermost layer is being pushed and pulled and reshaped, shifting up or down by as much as a kilometer or two in the places where the forces are strongest. One of the scientists involved described the whole idea as almost science fiction, and they were talking about a real measured published finding about the planet you're standing on right now. So the obvious next question is, what could possibly be strong enough to reshape a solid ball of iron the size of the moon? And the answer takes us back to that ocean of liquid metal surrounding it. Remember the outer core, the churning, turbulent sea of molten iron that swirls around the inner core and generates our magnetic field? Scientists have known for a long time that this liquid layer is violently turbulent. What they had never seen before was that turbulence actually reaching in and disturbing its solid neighbor on a timescale short enough for humans to measure. Vidal explained it simply. He said the molten outer core is widely known to be turbulent, but its turbulence had not been observed to disrupt the inner core on a human timescale. What we're observing, he said, is likely the outer core disturbing the inner core. Picture it, that raging sea of liquid metal, churning against the surface of the solid ball at the center, tugging at it, dragging on it, pushing its boundary in and out like a tide, sculpting a shoreline. Except the shoreline is made of solid iron, and the tide is an ocean of molten metal thousands of miles beneath your feet. That is what's happening inside your planet as you breathe. Now, I promised you authentic science, so here is the honest and important part. The part that separates real understanding from fear-mongering. Does any of this actually affect you up here on the surface, living your ordinary life? And the honest answer from the scientists themselves is this. For your day-to-day life, no, not in any way you would ever notice. The most measurable surface effect of the core's changing rotation is an incredibly tiny shift in the length of a day. When the core's spin changes, it can very slightly alter how long it takes the Earth to complete one rotation. But we're talking about a matter of milliseconds, thousandths of a second, so small that no human being could ever feel it. You will never wake up and notice the day was shorter. Your clock will never blink. These are changes measured by instruments so sensitive they can detect a wave that traveled through the entire planet. The scientists are careful and clear about this. This is not a doomsday. This is not a threat. What it is something arguably more profound. It's a window. Because think about what this really means. For the first time in human history, we have direct evidence that the deepest, most hidden part of our world is alive with motion. It slows, it reverses, it deforms, it responds to the forces around it. The center of the Earth is not a dead, frozen ball. It is a dynamic, changing, restless place, connected to the layers above it in ways we are only just beginning to understand. And that matters enormously because that same core, that same swirling system of solid and liquid metal, is what generates and sustains the magnetic field that protects all life on this planet. If we want to truly understand our magnetic field, how it forms, why it sometimes weakens, why over the long span of geological time it has flipped its poles again and again, then we have to understand the machine that creates it. And the machine that creates it is the core. Every one of these discoveries, the slowing, the reversal, the shape-shifting, is another gear in that machine finally becoming visible to us. The researchers said it themselves. This discovery opens a door to reveal previously hidden dynamics deep within the Earth's core, and may lead to a better understanding of the planet's thermal state and its magnetic field. And here's what I find genuinely beautiful about this whole story. Every single piece of it, the confirmed slowdown, the reversal, the changing shape, all of it came from earthquakes, from disasters. From the very same shaking that destroys buildings and takes lives on the surface, scientists have learned to read the deepest secrets of the planet. They turned catastrophe into a flashlight and pointed it straight at the center of the world. 121 earthquakes near a remote cluster of islands in the freezing Southern Ocean. Recorded on the far side of the globe, quietly rewrote what humanity knows about the heart of its own planet. And they did it without ever traveling more than a few miles below the surface. That is the power of human curiosity. We may never touch the core. We may never see it, but we found a way to listen to it. And what we heard was that it's moving, it's changing, it has a rhythm and a surface that shifts and secrets we've barely started to uncover. So the next time you feel the solid ground under your feet, and think of it as the most permanent, unchanging thing in your life. Remember what's happening 3,000 miles below. A ball of metal the size of the moon, spinning at its own pace, slowing and reversing on a 70-year rhythm, its surface flexing and reshaping under the pull of an ocean of molten iron. All of it invisible, all of it silent, all of it confirmed by science in just the last couple of years. The Earth you thought you knew has a hidden life. And we are the first generation of humans who ever got to hear its heartbeat. The story isn't finished. In the next 5 to 10 years, the scientists expect the core to swing back and start speeding up again. And they'll be listening for it, earthquake by earthquake, wave by wave, slowly filling in the picture of the strangest, deepest, most hidden place in our world. If this blew your mind even a little, do me a favor, subscribe right now, because we chase down the real confirmed science behind stories like this every single week. Drop a comment and tell me, before this video, did you even know there was a solid ball spinning at the center of the Earth? And share this with someone who thinks they know how their own planet works, because this is the kind of thing that changes how you see the ground beneath your feet. Thanks for watching. And remember, sometimes the biggest discoveries aren't out in space. Sometimes they're right beneath us, waiting 3,000 miles down for someone patient enough to listen.